Hello, welcome to Debug School. This time, reading error messages, part 1. This lesson is all about errors because they're that important. My advice is simply this. When you get an unexpected error, you should read them. Now, sure, this advice sounds obvious, right? But surprisingly, I have seen many instances where developers would avoid doing this very thing. They might look away from the error and try something random, just hoping that the error would go away. Which is basically like sticking your fingers in your ears and saying, la 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 la, I can't hear you. And needless to say, this is not a very effective debugging technique. But I can empathize with this because I too at times have avoided reading errors. I mean, computer errors can be pretty cryptic, right? If you come into programming from a user's perspective, most of the errors you encounter are so impenetrable that you are conditioned to think that computer errors are things you simply can do nothing about. But this is a mentality that can be changed. When you're responsible for the program that generated the error, then you have the power to fix it. And once you start getting the hang of reading errors and interpreting what they mean, it's going to seem crazy to ignore errors anymore, even if you don't understand what it's saying at first glance. That would be as if you were a detective at the scene of a crime and you found a note in the hand of the dead man, and when you open it up, you find that it was written in Chinese, a language that you don't happen to understand, and because of that, you decide to toss the note. Too bad I can't use that, you say. Now, what kind of self-respecting detective would do something like that? But in case you're still not convinced, here is why it's a good idea to read errors. Most of the time, it leads you towards where the problem is, and many times directly to the exact line of code where the mistake lies. But even in situations where it doesn't help you do that, and you needed to gather further evidence in order to solve the problem, still, going back and understanding what the error meant in the context of the problem is going to help you debug similar situations in the future. With that said, I'm going to show you a variety of errors and deconstruct how to read them and what they mean. Here, I have a JavaScript exercise from exercism.io called Bob. And Bob is a lackadaisical teenager who gives very limited responses. This exercise provides a test suite that I can write my code against. When I refresh the browser, the tests run. Currently, I have all 17 tests passing, which means that I've implemented the code correctly to the specification. Now, I'm going to introduce some mistakes just to see what errors they will produce. What would happen if I misspell this input variable? Why, I get an error. The first thing to do when you get an error is to read it out loud. So let's do this together. Are you ready? Reference error. Impt is not defined. The second thing to do is to look up the error location in your text editor. Now look at this big intimidating looking blob of text here. That is called the stack trace. For the time being, we're only going to focus on the first line of the stack trace, which is what gives us the location of the error. I have bob.js line 4, column 11. I will bring that up in my editor here. And that's exactly where I made the mistake. So in this case, simply following the error message directs me to the exact location of the mistake. Isn't that awesome? So when you encounter an error, do not panic. Instead, read the error message out loud. Next, pull up the location of the error in your code editor to get more context. And if you simply do these two things every time you encounter an error, you're already doing much better than those developers who are too afraid to look. Okay, let's try something else. First, I'll revert that mistake and let the tests go green again. Now, what happens if I misspell input over here this time? Let's see. And this time I get reference error, input is not defined. Now looking up the error location, that is line 4, column 11, exact same as last time. But this time we don't have a misspelling here. And this is because it's trying to use the variable input, which doesn't exist now because we've misspelled its original definition on line 3. So in fact, input is defined, but input isn't. Sometimes following the error location will not get you to the exact line of the mistake, but it can still get you pretty close. So let's try another one. This time, let's try misspelling var. And the error is reference error, Bob is not defined. And that is on bobtest.spec.js, line 2, column 17. So at the location of the error, Bob is being instantiated with the new keyword. The error tells us that there's a problem because Bob was not defined. Now, I know that I've misspelled var, so that must contribute to why Bob is not being defined correctly. But shouldn't there be an error message telling me that I hadn't defined Bob correctly in the first place? Why, yes, there is actually a second hidden error that you can only see when you open up the console. So let me do that right now. So from the View menu, I'm going to open up Developer JavaScript Console. There. So that's the console, and there is the error in red, which says syntax error, unexpected identifier. And this error has the location bob.js line 1. If I pull that up, that is exactly where I made the mistake. So for this case, as long as I know to look for the hidden error in the console, I was able to pinpoint the mistake. But still, that's pretty confusing. First of all, there were 2 errors, not 1. But moreover, one of those errors was way more helpful than the other. But that was the hidden one. What? Wow, no wonder people are afraid of errors. I'm going to go into more detail as to what happened. And to do that, I'm going to describe just a little bit about how browsers work. When a browser processes the web page, it works its way from the top to the bottom. For JavaScript files that are included using script tags, it's going to evaluate each script in turn, sequentially. And if there's an error when evaluating any particular file, it's going to acknowledge that error by printing it out in the console, and then move on to the next script. Now, it might be more logical to stop processing any scripts when the first error is encountered, right? But alas, that's not how browsers work. And this is why there can potentially be multiple errors. When you get more than one error, that just means you have multiple pieces of evidence to process. And you want to find all the errors, because otherwise you might be missing out on valuable information. Now, in order to do that, you want to know where to look. For browser-based JavaScript, you want to make sure that you look in the developer console. For other development environments, it might mean looking at the output of a terminal program or a log file. A lot of times, the errors are related. The primary error is the error that happened the closest to what went wrong, while secondary errors are side effects of that primary error. And in our instance, the syntax error was the primary error, which caused Bob to not be defined correctly. And that led to the second error when Bob was used in the tests. Now, I will talk more about syntax errors and their difference to runtime errors. In JavaScript, there are 2 main types of errors, syntax errors and runtime errors. Syntax errors are going to say syntax error right in their name, and everything else is a runtime error. When a syntax error happens, that means the computer didn't even attempt to execute the code because it had problems with it. A runtime error means that the machine had executed some of the code, but hit a snag along the way and had to stop prematurely. Now, just imagine that you're the king and you're fighting a war. And the means by which you orchestrate the fighting of that war is by exchanging letters with your commander. A syntax error would be like your commander wrote back saying that he doesn't understand your instructions, and is going to need clarification before he can do anything else. A runtime error, on the other hand, would be like if the commander has already started out the mission, but the troops ran out of food and cannot continue until reinforcements come. Syntax errors can look daunting, To give you a better understanding of why they say what they say, and their varying degrees of helpfulness, I'm going to dive a little bit into how the parser works. The parser is responsible for parsing code. And like humans, it reads code from left to right, one token at a time. A token can either be a word, operator, or punctuation. The parser reads these in one by one and tries to make sense of them. In this instance, it first sees the token var, and it says, oh, okay, so you're declaring a variable. And then it sees the token Bob, and it says, okay, so the variable's name is going to be called Bob. And then it sees the equal sign, and then it says, okay, so we're going to initialize this variable's value to something. Then it sees function, and then it says, okay, so we're beginning to define a function here, and so forth, and so forth. Now, what happens when there is a syntax error? To demonstrate that, I'm going to remove the assignment operator here. I get the syntax error, unexpected token function. Why does it say that? Well, from the parser's perspective, I see the tokens var followed by Bob. So now I'm about to declare a variable named Bob. But then when I see the token function, I'm confused. I would have accepted an assignment operator, a semicolon, a comma, or even a new line. But function here just doesn't make sense. Therefore, it's not valid JavaScript, so I'm going to have to bail out with an error. Here's another example. An error that programmers commonly make is that they'll sometimes forget to close a set of parentheses or curly braces. So that's what I'll do. I'm going to remove this closing brace, and I get this error, unexpected end of input. The error location is the very end of this file, and that's nowhere close to where I made the mistake. Why does this happen? Again, think about this from the parser's perspective. Since the body of this function was never closed, the parser continues reading all of the rest of the code as if all of it lived inside this function. When it reached the end of the file, it was still looking for the closing curly brace to end this function's definition. Now, the troubling thing about this kind of error is that it's just not very helpful for finding your mistake. The error location is way off. You do have other recourses though. At this point, if you have been taking small incremental steps, you would have had the option of reverting back to the last known good state. Otherwise, you can always use the test case simplification technique in order to pinpoint the error. Both of these techniques are covered in separate lessons. Okay, let's recap the things that we covered in this lesson. When you get an error, you should definitely read it out loud. Then, look up the location of the error in your editor in order to get more context. Know where errors come out when they manifest themselves because you want to get all the errors, because these things can really be helpful. And by now, you know the difference between syntax errors as opposed to runtime errors, which is important because they mean different things and you would approach them very differently. That's the conclusion of this lesson. I'm going to leave you with some exercises to work on. Please do these because it will force you to apply the concepts of the lesson and thus help you retain it for when you actually have to use it during a debug session. In part 2 of reading error messages, I'm going to show you the ins and outs of reading, understanding, and making the most use of stack traces. See you then.